Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. And today, we'll be looking at plotting lines on graph paper. And in this session, we plot lines, thus making use of the graph paper. However, for sketches of other quadratics, check out our videos on the quadratics playlist. And if you are interested on how to plot quadratics instead, make sure you check out our part 12 on quadratics. This is all on Numbers Simplified. Right, so before we start, let's look at the steps of plotting a line. So supposedly you're given a line y is equals to bx plus c, where b and c are real numbers. The first thing that you must do is construct a table of at least 3x values. Take note, 3x values, and the associated y values, i.e. x is equal to a. Then for you to get the associated y value, you're going to substitute for x with an a in order to get the y value. Step number 2, draw straight perpendicular lines, the x and the y-axis with uniform scales. Consider the scales given or appropriate ones if not given on the graph paper. Then of course, number 3, plot the xy pair or point on the graph paper. Step number 4, connect the points by a straight ruler. And lastly, note the points of intersection with the x-axis or a graph. So with this, we are going to start. Let's look at example 1 now. So using x values, x from -4 to 0, draw the graph of y is equals to x minus 5. And of course, the solution. The first thing that we have to do is to come up with the table of values for at least 3. In our case, we're going to select just 3 values of x that are between -4 and 0. And these values are -4, -2, and 0. Then we are going to calculate the associated y values. That is to say, when x is 0, y of 0 is going to be given by, so wherever we had x, we substitute that with a 0, so that we have 0 minus 5, which is equal to -5. We do the same thing for -2, so y of -2, wherever we had x, we now substitute with the -2, so that we have a -2 minus 5, which gives us a -7. We move on to the last value, -4. So y of -4, that would give us a -4 minus 5, which is a -9. Now that we have the x values with the associated y values, we are going to think about the scale to use. So according to the graph paper that we have on the right hand side, if we use 2 centimeters, so 2 centimeters is that one box, which is the bigger box. That is 2 centimeters by 2 centimeters is highlighted there. So if that one box would represent 2 units, that could fit on the y-axis. On the x-axis, it would still fit with the x values that we have, but why squeeze our work when we can actually make it 1 unit for the x? So for the x, if we go from -4 up until 0, we can actually fit the scale there. So 2 centimeters will represent 1 unit on the x-axis. However, on the y-axis, we might have a challenge a bit. So let's use 2 centimeters to represent 2 units, because for the y, the scale is a little bit wider. Now, we are going to express our values in terms of a table. That would be easier to read. So when x is -4, we got our y to be -9. When x was -2, our y was a -7. Our x is 0. Our y was a 5. Great. So now let's plot the axis, the x-axis and the y-axis. So that is how we would plot it. So using one unit from 2 centimeters on the x-axis and 2 centimeters representing 2 units on the y-axis, we are going to have that. But we could still use the same 2 centimeters to represent 1 unit in the y-axis as well. But for the sake of explaining the uniformity, I think that's still okay. That's still fine. So whatever you use as your x-axis scale, maintain that scale on the x-axis. The y can have a different scale, but maintain whatever scale you have. Right, so the next thing would be to plot the points individually. So we'll start with the first point. The first point is -4, -9. That is where it is located. So -4 on the x, -9 on the y. We move on to the next point, which is -2, -7. So -2 on the x, -7 on the y. We go on to the last point, 0 on the x, -5 on the y. Great, so we have our 3 points. Then the next thing would be to use a straight ruler. And on graphs, we use pencils. So we connect all the 3 points, place our ruler on all the 3 points, then draw with a pencil on top of these 3 points, so that we have a line coming out like that. So that would be our y is equals to x minus 5 graph. Now, why were we saying that you need at least 3 points? Let us look at this scenario. Now, supposedly, we have made one mistake. Say on the x is equals to -2, the y of -2 would give us, say, a -3, say, because it happens, especially when you are under examination setup, where you are under pressure. We all make mistakes. So for you to realize whether you've made a mistake or not, you might need the 3 points. With only 2 points, it might be difficult for you to see. Let's take a look at this scenario. So we have one of the points being wrong. So in this case, we know which point is wrong, and I've highlighted it with a yellow. So when you now come to plot your line using your ruler, you would see that you've got 3 points, but the 3 points are not connecting to a straight line. That automatically means that there is a mistake somehow, because it could either be this line that we have right now, that is the correct one, or it could be that we have the purple line, which is the correct one, or even the last line, which is the red one or orange one, depending on how you see it. So that indicates a problem. So it means that you have to go back to your drawing board. You have to identify the one that could have been a wrong value. Chances are high it's just one value, or even 2, or even 3 values that you've calculated, because there could be an error in the way in which you were calculating the values, and that would help you identify the mistakes beforehand. Now let's take a look at a scenario where one decides to just stick to 2 values instead of a minimum of 3 values in the x values. So we have one person who had 2 values, and under pressure, they made a mistake. So they calculated the y of -2 value wrong. So that would be what they would plot. They wouldn't even detect that they have made a mistake. So unlike the at least 3 points, it's easy to see where you have made a mistake and detect where the mistake is coming from. But if you just have 2 points, then you are likely to make mistakes and go away without realizing that you have made a mistake. In your thinking, you might assume that you've answered the question well, when you might have made a huge mistake. So take note, we need at least 3 values. Looking at example 2, using x values, x from -2 to 4, draw the graph of y is equal to -2x plus 1. and of course, the solution. We would need to identify at least 3 values of x, and the values that are between -2 and 4, because that is what we are given there, the range of values for x. So in our case, we are going to select -2, 0, and 4. The next step would be to calculate the associated values of these x values that we have selected. So we are saying that y of -2 would give us a -2 times -2 plus 1. What we have done here is substitute for x with a -2. So wherever we have x, we substitute that with a -2. Now, -2 times -2, we know that that would give us a positive 4 plus a 1, that would give us a 5. We move on to the next value, which is y of 0. So wherever we had x in our original equation, we are going to substitute that with a 0. So -2 times 0 would give us a 0 plus a 1, so that we get a 1. Moving on to the y of 4, wherever we had x, we substitute that with the 4, so that we get a -2 times 4, giving us a -8, plus the 1, we get a -7. We are done with that one. Now, the next thing would be to come up with a scale, a suitable scale. So from the x values, we see that from -2 to +4, according to the graph paper that we have on the right-hand side, we can actually fit all the values. If we use 2 centimeters, remember 2 centimeters is that one big box, dimension 2 centimeter by 2 centimeters. So if we use 1 unit from 2 centimeters, we can actually fit in all the values and still have more space. So we can use 2 centimeters to represent 1 unit on the x-axis. However, when it comes to the y-axis, because we've got values from +5 to -7, finding the difference between the two, that should be something close to 12. So we cannot have 12 boxes. So 12 would not be ideal. So we cannot use 2 centimeters to represent 1 unit. However, we can use 2 centimeters to represent 2 units on the y-axis. That will be the suitable scale. Now that we have also identified that, we can actually place our values in a tabular form, because it's easy to see when we are plotting our points. So now we say that when x is -2, the y is a +5. When x is 0, the y we calculated was a 1. And when x is 4, the y we calculated was -7. The next thing would be to plot the axis, the x and the y axis. So now we label that. So in plotting our axis, we need to be sure that we are going to represent each and every value that we have calculated and the values that we selected for x. So now we see that we can actually fit in the -2 to 4 values on the x-axis, and on the y-axis we have up until 8 and up until -8. So we can fit in all the y values. So perfect then. The next thing would be to now plot the points individually. So the first point that we're going to plot is a -2 on the x, which has a 5 on the y. So that one is plotted. Then the next point would be 0 on the x and 1 on the y, right there in the middle, in between 0 and 2. Then the last one would be 4 on the x-axis and -7 on the y. So it should be between -6 and -8 right there. And it should be in line with the 4. So we've got our 3 points. Now we place a ruler. These 3 points must connect. If they are not connecting, then it means that somehow there was a mistake that occurred. So we may need to go back to our drawing board to identify that mistake and rectify it. But now if all things are okay, then we plot our line and make sure to label your line and the axis as well, because that would count. So that's how you would plot that particular line. Now we move on to solve linear equations graphically. That is to say, using graph paper, we can actually solve these linear equations. Now let's take a look at example 1. So use graphical method to solve each pair of the simultaneous equations. So y is equals to x minus 5 and y is equals to minus 2x plus 1, and we are given this to be. So of course, the first step, we will need the table of values that are a list 3 values, because that is the range of x that we are given. Now we are going to select 3 values, a list 3 values. One of them is minus 1, 0, and the last one, 3. So now that we have 2 equations, we are going to separate them in this way. Let's call the first equation y1 and the second equation y2, so that it's easy for us to know which equation we are referring to in each and every step. So now, starting with y1, we are going to find the associated x values for y1. So when x is equal to minus 1, we are going to have y1 of minus 1. That is to say that wherever we have x in the y1, we are going to substitute that with the minus 1 so that we get the associated y1 value. So that would give us a minus 1 minus 5. That would add up to minus 6. Then we do the same thing for x is equal to 0. That is to say y1 of 0. Wherever we have x, we substitute that with a 0 so that we have 0 minus 5, which should give us a minus 5. Then we move on to the last point, which is a 3. y1 of 3. This gives us a 3 minus 5, which is a minus 2. So we have the y1 values associated with the x values that we have selected. We are going to do the same thing for y2. So you know that y2 is given to be minus 2x plus 1. So the y2 of minus 1 is minus 2 times minus 1. So wherever we had x, we are substituting that with a minus 1 plus a 1. So we know that minus 2 times minus 1 would give us a positive 2 plus 1, which adds up to 3. We do the same thing for y2 of 0. So wherever we have x, we substitute with a 0 in the y2 equation. That is to say, minus 2 times 0 gives us a 0 plus the 1. That would add up to a positive 1. Then, of course, lastly, we are going to have y2 of 3. Now, minus 2 times 3 plus 1. Minus 2 times 3 would give us a minus 6 plus 1, which should give us a minus 5. So we've got the associated y2 values for the x values that we have selected. So we can have this in a tabular form. So x is minus 1, 0, and 3. And the associated values in the y equation would be minus 6, minus 5, minus 2 respectively. And for y2, we are going to have for minus 1 in the x, 3 in the y2, 0 for x, 1 in the y2, 3 for x, minus 5 in the y2. Now that we have the tabular form, we can now proceed to the graph. So now we have our graph paper on the right hand side. Now we also choose a suitable scale. Now we see that on the x-axis, we can actually easily fit the values from minus 2 to positive 4 in the x-axis and minus 8 to positive 8 on the y-axis. So we can actually stick to this particular scale where we are saying that 2 centimeters would represent 1 unit on the x-axis and 2 centimeters to represent 2 units in the y-axis. Now the next thing would be to plot the points. So we'll start with y1. Moving from the right, when x is 3, we see that the associated y1 value is a minus 2. So we look for the 3 on the x-axis and a 2 on the y-axis, there where they intersect. That is the first point. Then we move on to the next point, which is a 0 on the x. and a minus 5 on the y. So the minus 5 would be in between minus 4 and minus 6, halfway through. There is no need for us to label each and every number. We can just stick to a uniform scale for the y. On the y scale, we have been moving with a difference of 2's. So we know that the midpoint would be the other number that we excluded, an odd number. So in this case, the minus 5 will be positioned there. Then we go to the last point on the y1, which is a minus 1 on the x and a minus 6 on the y. So where the two intersect, that is where we are going to get the last point. Now the next thing would be to use a straight ruler and place it on top of the 3 points. So the 3 points must be on the same line. If that is not the case, then you know that there is a problem and you need to go back to your calculations in order to see if everything was done perfectly well, because that might indicate that there was a mistake somehow. So let's suppose there is no mistake. Then you place your ruler on the 3 points and using a pencil, you connect the 3 points just like that. So in our case, we have that purple line, and don't forget to label your line. Y is equals to x minus 5. So that is the first line, the first graph that we have over here. So we are basically going to do the same thing for the second line, y2. So for that, we have the first point. So the first point here that we are going to use is from the left. So we have a minus 1 on the x with a y value, which is a 3. The 3 is in between the 2 and the 4 on the y-axis. So where the two intersect, that's where we plot the point. Then we have the x of 0 and the y of 1. So the 1 is in between 0 and 2 there. Then we also move on to the last point, which is 3 on the x and minus 5 on the y. So the minus 5 is in between minus 4 and minus 6. So where they intersect with the 3, that is where we get the point. So we must place the ruler first and be sure that these 3 points they're on the same line. If they don't fall in the same line, then it means we have a situation that we have to attend to. So supposedly everything is okay, then we just connect our 3 points. So connecting our 3 points, we are going to have that straight line here and label it y is equals to minus 2x plus 1. So it is important that you label your axis, the x-axis and the y-axis, and the lines as well, or any other graph that you may have. That is crucial, that is key. Now that we have plotted that, the next thing then is to identify any points of intersection, especially between the two lines that we have drawn, or it could be graphs that you might have drawn. So these are going to be important. When we look at our very own, we see that the two lines intersect at that particular point. I'll place an X over here so that I capture the point of intersection very well. So that particular point there should represent our solution. So now the solution would be a positive 2 on the X. So X is going to be a positive 2 and the Y would be a negative 3. Now, so that is the set of solutions that we have that satisfies the two simultaneous equations. Now, we can also check through other means. That is to say that we are going to substitute for these values into the equations, and these equations must be satisfied. Now, so when we consider the first equation, y1, x is equal to minus 5, where we have x, we are going to substitute that with a 2, and that gives us a minus 3. And take note, y1 would be minus 3 as well, because where we have y, we're substituting that with a minus 3. So that equation is satisfied. So let's check the second equation as well. For the second equation, y2, we have minus 2x plus 1. So where we have x, we are substituting that with a 2, so that we have a minus 2 times 2 plus 1. That should give us a minus 3. So that is the same thing we have on the left hand side as well. So that satisfies what we have. So those two are the set of solutions that we are actually looking for. And remember to subscribe so that you don't miss out on any of our future uploads. Make sure to check out all the other playlists we have so far. They might be beneficial to you, especially if you are a mathematics, statistics, financial mathematics student. And of course, I'll leave you with the following task. Find a question and post it on the related topic. Remember once again, your questions, feedback are always welcome here. Subscribe, like, and share so that you don't miss out on any of our future uploads. Thank you for watching Numbers Simplified. Remember, God loves you.